The only thing new is using the discriminant in the quadratic formula.
Okay. What's the discriminant?
B squared minus 4AC.
Okay, and the reason it has its own special name is because a lot of times the first thing you want to do when you have a quadratic is to determine whether or not you have real solutions or complex solutions. And that's determined by whether that is positive or negative. So you analyze the discriminant. If it's positive, you have real solutions. If it's negative, you have complex solutions. Okay? What kind of problems you got?
Gotta find another one. Well, one I had issues with was one on the homework. It's x squared minus 6x plus 11 equals 0.
Okay. So the homework said determine whether this has real or complex solutions?
Yeah, and then find solution.
Okay. So obviously it's not going to factor, so we're going to have to apply the entire quadratic. But either way, we got to figure out what b squared minus 4ac is. So let's plug it in. What's minus b?
6 plus or minus be 6 squared minus 44.
So that tells us that it's negative. So we know we're going to have two complex solutions because the discriminant is negative. If the discriminant is positive, we're going to have two real solutions, and if the discriminant is 0, we're going to have exactly one real solution because this plus minus won't have any effect if this is 0. So let's simplify this.
Negative 8.
And let's simplify that more. What's negative 8 simplified to?
I to root 2.
Good. Is that how you write it? You write it the I afterwards?
I put the I in parentheses just to make sure I don't put it under the square root sign.
I like it. Over 2. Let's simplify it more.
That's as far as I got.
Well, separate it into two fractions. What's 6 over 2?
3.
What's the rest of it?
3 plus or minus 1, root 1.
Well, I'm not going to write the 1. You still have the root 2.
Oh. Root 2i.
Uh-huh. And notice that the standard format for complex numbers is a plus bi. A is the real part. That's the complex part, or the imaginary part, rather. So you always want to get your answers whenever you have I in them to this format. In other words, we don't want to give this format that you get directly off the quadratic. That's not in a plus bi format. But the final answer we got is A is 3, that's B. So the two answers would be what? What are your two?
X equals 3 plus root 2I, and x equals 3 minus 2 root I.
All right. All right. So do you know what the factors would be?
No.
Okay. If I told you the solution was x equal 4 or x equal minus 7, do you know what the factors would be?
No.
They would be x minus 4 times x plus 7. In other words, work backwards. When we're solving a quadratic and we factor it, and we get this, then we end up with solutions of 4 and minus 7. Well, if you start with the solutions and you go backwards, you always subtract the solution from x. So it becomes x minus 4 times x plus 7. Okay, well, if we do the same thing with imaginary solutions, then the factors are x minus 3 plus root 2I and x minus 3 minus root 2I, which becomes x minus 3 minus square root 2I and x minus 3 plus square root 2I. So those would be the linear factors. In other words, that times that is going to equal that.
Okay.
Okay? So you want to know not only solutions, but what factors they translate to. In other words, if I take this, x squared minus x minus 6, and say that's equal to 0, that factors into x minus 3 times x plus 2. So I can say my solution is, my zeros are x equal 3 or x equals minus 2. Well, if I start with that and work backwards, this is what I get as the next step, and then multiply the two of them together and I get that. And you'll have to do this way. In other words, you may not have had it yet, but they will give you the solutions and expect you to come up with the polynomial as the question.
Okay.
Okay?
Yeah, we haven't had to do that yet.
No, but you will.
Don't doubt it.
What else you got?
I just have more of those.
That's fine.
Next one was similar, so it'd be negative x squared plus 5x minus 7 equals 0. And this one we just use the quadratic formula.
Okay. Now, we can use the quadratic formula. That's fine. What I would do if I was doing this problem is I would divide everything by minus 1 just to get rid of the negative that's in front of the x squared. But since I know that it's not factorable, it's not really a necessary step. It's not really going to help things that much. So let's just go ahead and plug everything we see into the quadratic formula.
Okay.
First thing,
You get negative 5 plus or minus square root of 5 squared minus 4 times negative 1 times negative 7.
all over.
2. Or negative 2.
That's why I don't like working with negative numbers, is because it's real easy to make mistakes like that. Whereas if I turn this into x squared minus 5x plus 7, not as many negative numbers after you plug it into the quadratic formula. But just make sure you are very detailed oriented when you use the quadratic formula. So what does this simplify to?
X equals negative 5 plus or minus square root of 25 minus 28 all over negative 2.
And let's put that in complex A plus BI format.
Plus or minus root 3i.
Okay, so we can switch this to root 3i. Now split it into two fractions.
X equals negative 5 halves.
What's that fraction?
Negative 5 over negative 2.
That's not negative 5 halves. That's positive 5 halves. Negative divided by a negative becomes a positive. What's the rest of it?
Root 3i.
Over negative 2. Now, here putting the negative 2, how do I explain this? Doesn't matter if I put the negative sign there or not because of this.
Okay.
Notice that if I use a positive 2, it's the same answer as if I use a negative 2. If I use the negative 2, which is proper to use, because I had a negative 2 in the denominator, it becomes minus or plus instead of plus or minus. So it still gives me the same two answers. What are my answers?
X equals 5 over 2 plus root 3 times I over negative 2. And then x equals 5 halves minus root 3I over negative 2.
Or I can use positive 2. Notice that it's the same thing.
Okay.
As long as I'm having a plus and a minus, then it doesn't really matter whether this coefficient is plus or minus. I'm going to get both of them. You see that?
Yeah.
In other words, if I use the negative 2, this plus becomes a minus, but this minus becomes a plus. So I still get the same two answers. They're just in a different order. Okay?
Okay.
Okay. What else you got?
2x squared minus 5x minus 3 equals 0. This one's quadratic formula, but it just says use exact solutions that approximate any radical solutions to the nearest hundredth.
Okay. I'm chuckling because you reach a level in math where you stop converting irrational numbers to decimals.
Mm-hmm.
Just because it's more accurate to say square root of 2 than it is 1.41 blah, 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 blah. I can express that number exactly by saying that. When I express it like that, I'm approximating it.
Okay.
So you tend to leave answers in radicals. Now, if you're building a bridge or something, and you get a radical, then it is necessary to convert it to decimals. So it's not like it's completely wrong to do that. But get used to leaving your answers in radicals. That'll be the more common way from now on. It's like pi.
Okay.
when you take the area of a circle, if you get 4 pi as the answer, you leave it as 4 pi. You don't convert that to 12 point whatever. 3.14 would be 12.52. In other words, leave it as exact as you can.
Mm-hmm.
And when you're dealing with irrational numbers, that means either pi or e or radical something. But anyway, I digress. So what's minus b?
5 plus or minus square root of negative 5 squared minus 4 times 2 times negative 3 all over 2 times 2.
Simplify.
X equals 5 plus or minus square root of 25 plus 24 all over 4.
And put it in. This had real solutions.
Yeah, x equals 5 plus or minus 7 divided by 4. X equals 3. And
Hold on.
x equals negative a half.
Hold on. Where are you getting 3 from? Oh, excuse me.
5.
Yep. So 12 or minus a half.
Yeah.
I was so stuck on complex numbers, I wanted to put it into 2 fractions. But you did it correctly. Okay. So far, you understand this stuff pretty good.
Yeah, we just did it today.
Good. Is there anything that you don't know how to do on this material?
Not yet.
Okay. Well, let's keep going.
First day of doing it.
You might jump to the, since we only have like 8 minutes, you might jump to the end of the exercises and see if there's some hard ones.
Okay.
Because I can see that you're finding these too easy. I mean, I don't mind, but if you want your money's worth, you want to do the problems you don't know how to do, not the ones you know how to do.
Last one on my set is 2x squared plus 7x equals negative 6.
Okay? What's the first step we're going to do here?
Put it in standard form.
Okay, which is to say what?
Add the 6 to get on the other side.
Okay. And now I presume this is not going to factor nicely given that what section we're on. So let's go ahead and use the quadratic.
Negative 7 plus or minus 49 minus 4 times 8 times 48.
Okay.
All over 4.
Oops. So this is equal to minus 7 plus or minus what?
1.
Okay.
All over 4.
So that's either minus 6/4 or what? It's minus 7 minus 1.
Negative 2.
Yeah. Okay. So have you noticed any difference on your grades? Are they improving? Is this helping?
Maybe a little bit. I mean, only took one test, and I did marginal on it.
Okay. Well, it feels to me like it'll help. The next test you take on this material, I feel like you're going to do real good on.
Yeah.
I mean, you haven't.
It's just remember, because as part of our test, you basically have to memorize all the formulas, and I
Well,
mix them up.
let me give you a little bit of help on how to memorize this. I think you got it memorized, but
Yeah, that one, and I get it, and I can do it in the homework, but then when I have to take a test on that uses 6 different formulas.
okay. Notice what the first half of this is. It's the same as the vertex of a quadratic, minus b over 2a. And the rest of it is plus or minus the square root of the discriminant. So as long as you remember that the discriminant is equal to b squared minus 4ac, you can always come up with the quadratic. In fact, you can always calculate the quadratic based on completing the square. If I have ax squared plus bx plus c equals 0, I can complete the square in exactly the way we've done. And what I'm going to end up with is x is equal to the quadratic formula. That's how they came up with the quadratic formula, was by completing the square when it's in this format. So what are some of the other formulas that you have forgotten on a test? Do you remember any? Because memorization, a lot of times if you can remember a few tricks to memorize stuff, it really is helpful.
What was the other one?
You got into exponents yet?
Within what?
You know what this is equal to?
3. You don't just add them?
Yep.
Yeah.
What is this equal to?
You just subtract them?
And what is this equal to?
Multiply them.
Okay.
And I know on the last test I mixed up when to use vertex versus quadratic, but we don't really use that anymore.
Well, say you have vertical motion, or motion of a particle.
Mm-hmm.
This is always a quadratic. And the questions you're going to get asked is, this type of problem would be, okay, you throw a ball into the air, goes up in a parabolic motion, comes back down, hits the ground. How high does it get? And when does it hit the ground? All of which involves factoring this quadratic or solving this quadratic. And the way to figure out how high it gets is to solve for the vertex, but not the x-coordinate of the vertex, but the y-coordinate of the vertex. In other words, you use minus b over 2a, which gives you the x-coordinate of the vertex, plug that answer into this formula, and that'll give you the y value when t is equal to that point right there. In other words, if I put a coordinate system on here, this is what I'm looking at. So if the question says, when do you reach the maximum value of this ball thrown into the air, it's going to be where the vertex occurs.
Okay.
And if they say, when does the ball hit the ground, well, that's where y is equal to 0. So I have to factor that quadratic to solve for t, and that will be the answer to when the ball comes back and hits the ground. So there's a lot of places where you would use vertex, especially on problems like that, physics type problems, where they're asking you to solve projectile motion type problems, which are always quadratics, because whenever you throw a ball into the air, it always follows a parabolic path. It might not be this, it might be this, but it's always a parabola, which means it's always a quadratic. Anything else, Silas, you want to go over, or is that it?
I think that's it.
Well, sounds like you're pretty good to go on that, on this material. You didn't make a mistake all night.
That's refreshing.
Well, just hold on to it. Just maintain that confidence when you go in and take those quizzes. Know what you know, and know that you know it. Okay?
Okay.
I will talk to you tomorrow night.
Okay.
Bye-bye.